Now let's review simplifying radicals. So remember, when we are simplifying a number inside of a radical, we want to try to think of what numbers multiply to that number that we can take a square root of. For example, we know that 150 is the same as the square root of 15 times the square root of 10, except we can't take the square root of any of these numbers. So even though eventually you'll get to the right answer, it will take you a little bit longer. Let's try to think of maybe two other numbers that we can multiply together to get 150. If you said 25 and 6, that is the easiest way to simplify this radical. So the square root of 25 is 5, and we cannot take the square root of 6, so our final answer is 5 root 6. For the square root of 6 times the square root of 20, we would first want to multiply those two numbers together. So we know that 20 times 6 is 120. Now we want to try to think of two numbers that multiply to 120, and we are hoping to find one of those numbers that is a perfect square. So we know that the square root of 4 times the square root of 30 will multiply to 120, and we can take the square root of 4. It is 2. Now let's see if the square root of 30 will simplify further. 30 can be broken up as it is the square root of 15 times the square root of 2. We can't take the square root of any of those numbers. Even if we tried to break up 15 even more, we still can't take the square root of any of those numbers. So 2 square root 30 is the most that this can be simplified by. So that is our final answer. The square root of 90x to the 5th y to the 8th z. So if we have numbers and variables together, what we want to do is first split everybody up. So we're going to simplify the square root of 90, simplify the square root of x to the 5th, simplify the square root of y to the 8th, and the square root of z. So let's think of two numbers that multiply to 90, and hopefully one of those numbers we can take the square root of. If you thought of 9 and 10, that's great because we can take the square root of 9. It is 3. So 3 root 10 is the most that 90 can simplify to. Now let's work with x to the 5th. Remember, for variables and exponents, we want to try to break it up in terms of x squared. So x to the 5th is the same as x squared times the square root of x. The reason that we break it up in x squareds is because we can take the square root of x squared. So we get x times the square root of x. We want to do the same thing with y to the 8th. And remember, we learned a little trick in class that makes this go a little bit faster. You can always divide the exponent by 2. So 8 divided by 2 is 4. So we have y to the 4th, and that would be our final answer. There's nothing left inside the square root because there's no remainder. If we did the same thing with the square root of x to the 5th, we know that 2 goes into 5 twice, and there's a remainder, so an x stays inside the square root. That's how we got x squared times the square root of x. And we can't take the square root of z, so we just leave them inside. So now, let's write our final answer. We have a 3 on the outside, we have an x squared on the outside, and a y to the 4th. So 3 x squared, y to the 4th, and we have a square root 10, a square root x, and a square root z. So inside the square root will be 10x z. So the final answer for this problem is 3x squared y to the fourth square root 10x z. Moving on to the square root of 9 over 100. So remember, for fractions, we are allowed to break it up as the square root of 9 over the square root of 100. Luckily, we could take the square root of 9, it's 3, and the square root of 100 is 10. So our final answer is 3/10. For number 5, we are not allowed to have a square root in the denominator, so we need to rationalize it. So remember, to get a square root out of the denominator, we multiply by the square root of 6 over the square root of 6. So the numerator becomes 7 square root 6 all over 2 times, and remember, whenever you multiply a radical by itself, it just becomes that number. So square root 6 times square root 6 is 6. So our final answer is 7 root 6 over 12. Remember that if you multiply 7 and root 6 together, it is not the square root of 42 because this 6 is trapped inside the radical. So we're not allowed to multiply 7 and 6 together. Let's work on the square root of 27 over 8. Unfortunately, we cannot take the square root of any of these numbers, but let's break it up and then try to simplify it. So we have the square root of 27 divided by the square root of 8. First, let's simplify the square root of 27. We know that that's the same as the square root of 9 times the square root of 3. And we know that 8 is the same as the square root of 4 times the square root of 2. The square root of 9 is 3, and that root 3 is just going to stay there. The square root of 4 is 2, and that root 2 is going to stay there. So now, unfortunately, this is not the final answer because we still have this radical in the denominator, and he's not allowed to be there. So what we need to do is multiply by root 2 over root 2 to get him out. That will make the numerator 3 square root 6. Because the 3 and the 2 are both inside radicals, we're allowed to multiply them together. And the bottom will become 2 times root 2 times root 2 is just a regular 2. So our final answer is 3 root 6 all over 4. Now remember, you would not be allowed to cancel the 4 with the 6 at all and reduce it because the 6 is trapped inside the radical.